Hey everybody, we are going to be jumping into section 8.3. That is talking about mean, median, and mode. So this is probably something that you've heard of before, have probably messed with before. One thing I do want to make note of before we get super far into this is this phrase right here, measures of central tendency. When you hear that phrase, it sounds like it's going to be something that's kind of difficult to figure out, or you're kind of going like, what does that mean? Measures of central tendency. All right, well, let's break it down a little bit. Measures means a measurement, okay, or an evaluation of something. Central means about the center, and then tendency is where does it tend to go when it's in the center, right? So when we say measures of central tendency, what we're really talking about is the mean, median, and median. Now, will the mode occasionally be in the middle of the data? Sure, that's definitely possible. But when we refer to measures of central tendency, really what we're looking at is the mean and the median, right? Remember, we're going to talk about this on the next slide. Remember that median is the center of the data, and mean is the average of all the values in the data. So when you hear measures of central tendency as we move throughout this lesson today, let's keep in mind that that's what that means. All right, so discussing what the mean, median, and mode represent. So we have the number that occurs the most often, okay? And that's considered to be the mode. The number that occurs the most often, we say is the mode. If two values occur the same amount, we call this data bimodal. Now that's where we stop, okay? There's no such thing as trimodal, quadmodal. No, those don't exist. If there are more than two modes, we simply say there are no modes. Okay, so for example, when we say that, what I mean by that is if you have a set of data where, let's say it's a list of 15 numbers, and so you have 3 4s, 3 5s, 3 6s, 3 7s, 3 8s, right? If we're looking at that, there is no mode. There's no number that occurs the most often. They all occur the same amount, okay? Yeah, they might appear more than once, but then we still would say that there is no mode. Now, the next thing that we're going to look at is the median. The median is the middle of the data. Now, with the median, okay, a couple things to note. The numbers have to be in order. So that's one of the first things that you have to do. It can be one of the more tedious things that you have to do, but you want to make sure that it's in order. Okay, then you find what's in the middle. Now, you might be saying, whoa, what if there are two numbers in the middle? If there are two numbers in the middle, then you add them together and divide by 2. So if there's two numbers that happen in the middle, add them together and divide it by 2. And lastly, we have the mean, okay? So the mean of the data set is the average, okay? And you find the sum of all the data values, and then you divide it by n, which is how many data values there were. Or there were, or are, rather. All right, before we move into some examples, because that's where we're headed next, I'm going to add in a slide here and talk about a couple things that matter when we're talking about measures of central tendency, okay, because that's what we're also going to be looking at as we move throughout this. So when we talk about those measures, which remember are mean and median, sometimes you're going to be asked the question, what represents the data the best? Which measure of central tendency represents the data the best? Okay, so when you're asked that question, you might be like, I don't know, pick one, whichever one you like. I like 17, 17 looks good. No, we actually have something that we look at to determine if we should use mean or median. So what we use to determine that is if there are outliers. Now outliers, okay, are values that are pretty far away from the middle of the data, okay? So they're values that are either way above or way below the rest of the data. have a way to kind of use a rule of thumb to figure out if there are outliers. And we'll look at that a little bit more in the next section. But for right now, just think of outliers as really, really big numbers or really, really small numbers that don't coincide with the data that you have. So you want to use mean when you have no outliers. And you want to use median when you have outliers. Okay, now why might that be the case? Well, if we're talking about the center of the data, okay, if we're talking about what actually truly represents the data, then what you want to use is something that actually represents it. So let's think about salaries in a company. All right, let's use that as an example. Salaries in a Fortune 500 company. All right, so in that company, there's going to be somebody that's like the COO, CEO, all those things. Those people are going to be making probably a significant amount of money. Then you also have people that are maybe entry-level workers, new to the company, whatever. They're probably making not so significant amount of money. So if we factor in, right, so let's say that those people that are kind of the entry level, they're making $40,000. Let's say these people that are the CEOs are making $1.5 million. Well, if you average those together, it's going to look like everybody at this company makes a ton of money. But that's not necessarily true, right? Because the CEO, the COO, they probably have outlying salaries that are way above what the rest of the data is. So normally with companies like that, they're going to give you what their median salary is. Okay, where does the middle of the data fall, right? Because then you're ignoring the outliers on either side of the data, because we'll see in a minute, because you can mark them out as you go, and then it gives a true representation. Same thing with even living in Hendersonville. When you decide to move to Hendersonville, what you probably want to look at is the median cost of living. The reason for that being because there are houses here that are worth millions and millions of dollars. And yeah, of course, there's a few on the lower end that can kind of try to balance it out. But we have quite a few places around here where people have lots and lots of money. So you want to look at that median cost of living. Okay, so just wanted to touch on that before we go into any examples. All right, so we're asked to use the given stem and leaf plot to determine the mode, median, and mean. All right, so the mode, that one's always fun to look for. We're just looking for which data value occurs the most. So taking a look at this, I see that 90 happens twice. Oh, 112 happens 3 times. 120 happens twice. All right, so it looks like 112 would be our mode. And that's always what I start with. First thing that I do when I'm looking for mode is I start looking at, okay, what data values appears more than once? Okay, working off of that, now how do I, move it up? So the nice thing about stem and leaf plots is the data is already in order from least to greatest. So this data goes from 88 to 134. And so when we go to do the median, we're going to mark numbers out as we go till we get to the middle. Let's do it. So starting with 88, we're going to mark that out. And we're also going to mark out 134. 89 and 131, 90 and 131, 90 and 130, 97, 127, 2, 25, 105, 123, 106, 120, 107, 120, 108, 119, 111, 119, 120, 112, 117, 112, 115, and then we see that we do have 2 data values that are in the middle. So for the median, we have 112 or 114 that could be, so we take the average of those 2. And we get 113. And I'm going to show you some technology tricks here in a moment. Also, I broke it. Hang on. We've come too far. Okay. So now we're going to get rid of this. Okay, and now lastly, we need to find the mean. So let's figure out how many data points there were. 28 data values. Okay, and now we know too that we did the median correctly, which maybe we should count that first, because whenever you have an even number, the median is going to have to be the average of the two numbers in the middle. So what I'm going to try to do is split my screen, and we're going to pull up Desmos. Come live over here. Let's see if I can zoom in on our data values. Okay, great. All right, so what we're going to do at first is we're just going to find the sum of all of the values. Okay, so we have 88, 89, 90, 90. No, this is not very exciting, but all right, there we go. So we've put in our data points. So we get a sum of 3154. There were 28 points, and so we're going to divide by 28, and we get that the mean should be about 112.64. So let's see if I can get the PowerPoint back up. And so again, we just add all those values up, divide it by that 28, and then that leaves us with the mean. So in looking at this data set, again, it goes between 88 and 134. You can see that mean and median, if we were to round the mean, we'd round up to 113. So they're pretty similar. I would also say that looking at this data, you don't have an outlier. Now, if there was a random like 12 before the data started, like a 12 up here, then yeah, we might consider that an outlier and we should probably use median. But with this data, it doesn't look like we have an outlier, so we are good to use mean as the best measure for central tendency. I'm gonna throw something. Oops. All right. So next up, we have this list of numbers, and we're trying to find the mean, median, and mode, or mode, median. What I always do when I have a set of data like this, it's all out of order, the first thing that I stop and do before I even start looking for the mean or anything is I have to put it in order. My brain can't look at a set of data like this and just be fine with it being all jumbled up, so I have to go ahead and put it in order. So I see we have 2 zeros. We've got a 1. So we got 2 2s. So we got a 3, a 4, 7, 8, and a 9. And we got 3 11s. And we have 12, 13, 14. So already looking at this data, I can see mean is probably going to be our best measure of central tendency. We don't have any outliers. We can see that the data goes between 0 and 14. There's no gaps in the data, so we're good there. So what also helps when you put the data in order is to help you go ahead and find the mode. So you know which number you wrote down the most. In this case, it is 11. All right, and then to get the median, we start marking those numbers off till we get to the middle. All right, and so again, we have place where we're stuck and we have to figure out the median from the two numbers that are in the middle. So we would add 7 and 8 together and divide that by 2. And so our median would be 7.5. And it's okay when you have to do the average for the medians, it's okay to have a value that's not actually in the data set. So even though if somebody were to ask you, well, you said the median was 7.5, but there is no 7.5 in the data. Yep, we know, but that's because we had to take this average of 7 and 8, which were the two numbers in the middle. And so then lastly, we want to go to our mean. And we want to figure out what we're dividing by. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 numbers. So we have 16 numbers. That's what we'll end up dividing by. So let's go ahead and find the sum of all these points. And we will see if we can do our double panel again. And let's see. So if we got most of the values, I might have to scroll a little bit, but it'll be all right. So we start with 0. Of course, you don't really have to add the zeros. We know that that's not going to do anything, but it's still good practice to include all your numbers. I'm going to scroll. 3 11s in a row. 12, 13, and 14. So the sum of this comes to 108. We do 108 divided by 16. And so our mean is 6.75. Again, like we talked about from the jump, mean is going to be your best measure of central tendency here because we don't have any outliers. All right, so I'm going to be quiet for a minute. Go ahead and pause the video, and I want you to take a minute and see if you can figure out mean, median, mode, and decide which measure of central tendency you think is best. All right, so first thing we got to do is put them in order. So we have, let's see, 19 first, then 21, 28, 48, 59, 62, 63, got two 66s, and then 79 and 94. All right, so with this data set, before we get going looking for our 3 characteristics, let's talk about the spread on this data, okay? So we start at 19, we hit 21, we hit 28. Those are pretty much clustered pretty well together, okay? Then we go to 4, then we have a big jump. We're jumping 20 numbers. We go to 48, 59, 62, 63, 66, 66. Okay, again, those are pretty similar. I would even include 79 in there. The issue becomes, and when we talk about the outliers, is if there's like a bridge to that next big number, right? So if we saw it was 66 and then the next number was 94, 79 didn't exist, we would say 94 is an outlier. Same thing kind of with the 28 to 48. It bridges that gap just a little bit. And so sometimes when you're looking for an outlier, and like I said, in the next chapter, we're going to talk about a little bit more how to exactly find them. But sometimes if there's like these little numbers that sort of bridge the gap, instead of there being just this wide 40 point difference, sometimes when we see those, we actually can't consider them outliers. But I want to do something different with this problem. I want to just kind of take a look at the data in a Google Sheet. Because we could do some cool things with Google Sheets as well. This is the same as for Excel. I'm just trying to use something that everyone or most people have access to. All right, so I'm going to put the data in. Maybe. I know if you just did this whole thing by hand, you're going to just rue the day that I was born, but you are going to have to be able to do it by hand for the final. So it is important to know how to set these up by hand. One of the things that Google Sheets can do is also organize your data for you. Okay, so what I mean by that is if you get a set of data that's all wonky, it's not in order, you're feeling like, I don't want to do this, you can have it sort from A to Z, and that will put the data in the proper order. Let's take a look, though, at the graph of this data. I just want to take a look at what it looks like, kind of see the spread of it. And so we're going to insert chart. I would like it to be a box and whisker, if it will let me. Not feeling like it. All right. Yep. Okay. Let's do it like this. All right. So looking at this data here again, you can kind of see just how it goes up from left to right. So I'm going to get a box and whisker plot on here to show you a little bit better, to where you can see if there is gaps in the data. And so we can see again that the data, even though it does kind of go all over the place, it is still technically all together. There are no outliers. So let me get rid of this chart real quick. Now let's talk about how we can solve for mean, median, mode using Google Sheets. So when you want to use a command in Google Sheets, you do equals and then whatever the command is. So let's do mode. Then you just highlight your data. So equals mode in all caps, highlight the data, press enter. The mode is 66, which we can see that 66 occurs twice. It's the only value that occurs twice. So that's kind of nice. Google Sheets can also do median. So equals and then median. And then just drag your data down and we get 62. So again, if we were to go through and mark the data out, I don't know why I typed those in backwards. And okay, that's fine. And then you can also do equals, and then for Google Sheets, it's going to be average instead of mean. And so you do enter, mean, and you get 55. I don't know how I typed those out of order. Okay, I'm sorry about that. So anyways, you also have these computer shortcuts that can help you. Desmos also has a feature where you can find the average in the data set. Go away, little guy. So if you go to the keypad on Desmos and then functions, you can do mean, median. I don't think it does mode just because you can kind of see it, but you can do mean and then you just type your data in with commas in between and it'll find the mean for you. So Desmos can also do this shortcut. All right, that is it from me for 8.3. I'll see you for 8.4.